Okay, today we're going to look at Chapter 12, Review of Conic Sections. If you recall, there was quite a bit in this chapter, and we're going to kind of go through it a little bit quickly, so you may have to go back and review your notes from Chapter 12 to help you with the homework assignment on the study guide questions. But we'll go through it pretty quickly and then give you time to work on the study guide. So when we're dealing with conic sections, a couple things we have to remember. First of all, we're going to take a look at a point x1, y1, x2, y2, and the distance formula, distance between those 2 points, is square root x2 minus x1 squared plus y2 minus y1 squared. My midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's look at a word problem here. During math class, a fly lands on your graph paper. It lands on a point 1 unit from the left side of the paper and 2 units from the bottom of the paper. Now, for the purpose of this problem, we'll assume that the lower left-hand corner is your origin, 0, 0. Before it flies away, it walks in a straight line to a point 6 units from the left side of the paper and 4 units from the bottom of the paper. How far did the fly walk? Round to the nearest unit. Well, I'm going to look at it this way. Distance is x2 minus x1 squared. So x2 was a 0.6 units from the left side. x1 was a 0.1 unit from the left side. So 6 minus 1. And then my y value, 4 units from the bottom of the paper is y2, and 2 units from the bottom of the paper was y1. So if I do a little bit of math here, 6 minus 1 squared is 25. 4 minus 2 squared is 4. 25 plus 4 is 29. Square root of that is approximately 5.385, which is approximately 5 units because it asks us to round to the nearest unit. So going back to our geometry days, hopefully you can remember some of that. All right, let's take a look at some more stuff that we learned in Chapter 12. First of all, the formula for a circle is given there, where H and K are going to be the center. So now let's look at a problem. A tape measure is coiled in a circular roll described by the equation x minus 1 squared plus y squared equals 25. The tape is pulled out in a line tangent to the circle at the point -3, 3. So write the equation of the line of the extended tape measure. So that's going to be a tangent line that's going to have a point -3, 3, and we have to figure out what the slope of that line is based on what the center of this circle was. Because the center of the circle to this point is going to be perpendicular to the tangent line. So first find the slope of the line from the center to the point on the circumference. Well, our center is going to be at 0. I'm sorry, at 1, 0. So 3 for my y value, 3 minus 0, divided by my change in x, which is going to be -3 minus 1. And my slope of the line from the center to the point on the circumference is -3/4. So the slope of the tangent line then is going to be the negative reciprocal of that. I'm going to call that m prime. That equals 4/3. So now I can use the point slope formula to find the equation of the tangent line because I have the slope of my line and I have a point. So y minus y1 is equal to m prime x minus x1. Well, my y1 is going to be 3. So y minus 3 equals 4/3. X minus -1 is x minus -3 is x plus 3. And so I have y equals 4/3 x plus 7. Okay. All right. We also talked about ellipses and how to uh, draw them. There's quite a bit of information on this slide that you're going to want to um, keep handy for your working on your study guide. I'm not going to go through every line on this right now, but I did want to look at this problem here. Determine the foci, vertices, and co-vertices. So here, my A is going to be 4, because it's going to be the square root of 16 here. My B is going to be the square root of 9, which is going to be 3. And my C squared from this equation here is going to be 16 minus 9 is 7, the square root of 7. So my center is at 2, -1. My vertices are at, for using this equation up here, H, okay, which is 2 plus or minus A, which is 3. I'm sorry, 4. And then K, which is -1. And then your co-vertices and your foci. So I'll let you figure this out. I don't want to go through each one of these individually. That will take too long. But you can figure that out on your own using these formulas up here. All right, hyperbola. Okay. We had some things going on here. Remember, A is the first term's denominator, and we have vertices x, y. B is the second term's denominator, which creates the box in the center of the um, hyperbola. C is the foci. Okay. Asymptotes are the dashed lines drawn through the center and diagonal points of the box. So here are some things that we're going to remember. Order matters. So here I've got a vertical hyperbola, and here I have a horizontal hyperbola. And you're just going to want to keep these things straight. Okay, I don't want to go through each one of these individually now because that will take too much time, but you can look at this. All right, we also looked at parabola when only one of the terms is squared. So, and here are some things that we're going to want to remember. But given y minus 3 squared is equal to -4, x plus 2, identify the focus and directrix. P here is the distance between vertex and the focus. So looking at -4 here, 4p is equal to -4 from this equation up here. So p is equal to -1. My vertex is at -2, 3. And my focus, using these equations here, is going to be at -3, 3. My directrix from this equation here is going to be equal to x equals -1. So I'll let you jot that down. But again, I don't want to go through each step individually because it'll take too long. All right, let's graph this. I've got x minus 4 squared over 9 minus y plus 2 squared over 16 equals 1. Well, what do I have here? I've got h, k, a, b, c. From this first one here, I know it's going to be a hyperbola, a horizontal hyperbola. And my a squared is equal to 9, my b squared is equal to 16, my c squared is equal to 25, so c is going to be equal to 5, H is 4, K is -2, A is 3, B is 4, C is 5. So my center is going to be at 4, -2. My vertices from my one of those previous slides that shows how to calculate the vertices of a hyperbola. The asymptotes, y equals plus or minus 4/3 x minus 4 minus 2, and the foci are listed here. And if I were to graph this, it would look something like this, with my center at 4, -2. Here's my box in the middle here. Here's my asymptotes. Here are the vertices here, and here are the foci in dark blue here. So I'll give you a second to jot that down, but you're probably gonna have to come back and finish up this slide later. All right, again, you'll have to come back to that one. So application problems, engineers are building semi-elliptical pedestrian bridges. So semi-elliptical means it's gonna be half an ellipse. Okay, so we're gonna be just looking at the part that's above the x-axis. The larger bridge will be 1.5 times as wide and twice as tall as the smaller bridge. The equation for the bridge over the smaller highway is x squared over 196 plus y squared over 100 equals 1, measured in feet. Find the dimensions of the larger bridge and then find the equation. So let's sketch this out here. It's going to look something like this, right? Now, my h is 0, my k is 0, my a is the square root of 196, my b is the square root of 100. So my vertices are going to be at 0, plus or minus 14, 0, 0, 0 plus or minus 10. So that tells me that this distance is 14 and this distance is 10. Now I'm told that the larger bridge, it's going to be 1.5 times greater than this and 2 times taller. So it's going to look something like this. 1.5 times as great as this is going to be 14 times 1.5 is 21. And 2 times as tall is going to be 20. So now, what do I have? My h prime, if I want to call it that, for the second bridge is 0. My k prime is 0. My that prime should be on the side. A prime is equal to 14 times 1.5 is 21. B prime is 10 times 2 is 20. So my vertices are at 0 plus or minus 21, comma 0, and 0, comma 0 plus or minus 20. Again, we're only looking at the part that's above the x-axis, so we're not looking at the negative, the vertices. Okay, so my equation would be x squared divided by 21 squared plus y squared divided by 20 squared is equal to x squared over 442 plus y squared over 400 equals 1. Okay, we'll continue on. I realize there's a lot of notes here, but I do want to get through this. All right, writing standard form equations. Okay. Remember how to complete the square. Okay, we're going to add b over 2 squared to both sides to complete the square for something like this. Okay, so let's take a look at what we have here. We have x squared minus 4y squared plus 8x minus 24y minus 24 is equal to 0. So I'm going to gather the x terms together. So x squared plus 8x plus negative 4y squared minus 24. And I'll move the constant to the other side is equal to 24. So now, how do I complete the squares of each of these? For the 8x, I'm going to take half of that, which is going to be 4, and square it. So that's 16. Here, I'm going to factor out a negative 4. So I have y squared plus 6y. Well, half of 6 is 3. 3 squared is 9. So I do have to then add 16 to this side as well. If I add 16 here, here I'm subtracting 4 times 9, which is subtracting 36. So now I can collect like terms and write this as 4x plus 4 squared minus 4 times y plus 3 squared is equal to, if I combine like terms here and add it up, is equal to 4. Now divide both sides by 4, and I've got x plus 4 squared over 4 minus y plus 3 squared over 1 is equal to 1. And there's a lot of notes there, but I think you can get that. And then we could graph that hyperbola if we wanted to. So it is a horizontal hyperbola. All right, let's take a look at another one. An airplane makes a dive that can be modeled by this equation, where x and y are measured in hundreds of feet. Let the ground be represented by the x-axis. How close to the ground does the airplane pass? Well, I went ahead and graphed it, and we're going to look at the top part of this above the ground, assuming that the x-axis is the ground. We'll ignore this part underground. So we're just going to look at this part of the flight trajectory. Well, I'm going to rewrite this, put the 236 on this side, gather my x terms together, gather my y terms together. Okay. And here I have negative 9 x squared plus 4x plus 25 y squared plus 2y is equal to 236. Complete the square by adding 4 to this. Okay, that means I have to subtract 36 because I have 4 times negative 9. I have to subtract 36 here and add 1 here times 25. So I'm going to add 25. So this becomes negative 9 x plus 2 squared plus 25 y plus 1 squared is equal to 225. Well, I can tell that this is going to be a vertical hyperbola, so I'm going to write it in this order. Y plus 1 squared, and I'm going to divide through by 225, is going to leave me with y plus 1 squared over 9 minus x plus 2 squared over 25 is equal to 1. That tells me that k is equal to negative 1, h is equal to negative 2, a is equal to the square root of 9 is 3, b is equal to the square root of 25 is 5. That tells me my vertices are h, comma, k plus or minus a. Again, we're only worried about the one that's above ground, so h is negative 2, and my k plus a is going to be negative 1 plus 3 is 2. So that's going to be at negative 2, 2. So the closest it gets to the ground is that y value of 2, which is 200 feet above the ground. So again, a lot to think about, but I think you've done enough problems like this that you should be able to get it. A lot of notes there, I know. All right, we'll continue on, and if you need to come back, you can get these notes or take a screenshot and grab them. All right, classification. If I have this form of the equation, I can determine whether or not it's a parabola, ellipse, circle, or hyperbola just by looking at the coefficients and what we have. So if only one of these terms is squared, then it's going to be a parabola. If x squared plus y squared, it equals an ellipse if a does not equal c. If x squared plus y squared equals a circle if a equals c. So if these two coefficients are equal, then we're looking at a circle. If it's x squared minus y squared, then we know we have a hyperbola. So looking at this, I've got an x squared plus a y squared, but the coefficients are different, so that's going to be ellipse. Here I've got an x squared minus y squared, so that's going to be a hyperbola. Here I've got an x squared, and if I bring the y squared over to this side, it's going to be x squared plus y squared, so that's also going to be an ellipse. So hopefully these are not too hard. All right, algebraic methods of solving systems of equations. We talked about the substitution method, how to do that. Substitute one variable in for the other in the other equation. I'm not going to go through a big long explanation of that now. If you need to go back and check your notes, you can do that. Elimination, okay? You want to get two variables that are the same but with different signs, and then you can add the equations together to eliminate one of those variables, solve for that variable, and then plug it back into the original equation to get both variables. All right, so like I said, I'm not going to go through a big long explanation now, but you should be able to remember how to do that. We can also solve by graphing. So enter the equations into your graphing calculator. Well, if it's a square root, then we have to divide this into two equations. Okay, so here I've got x squared plus 8y squared minus 4 is equal to 0. I can't plug that directly into my calculator, so I have to solve for y. So 8y squared is equal to negative x squared plus 4. Y squared is equal to negative x squared plus 4 divided by 8. Then y is going to equal plus or minus, okay, that square root, because we're going to have to take into consideration both the positive and negative. So I'm going to divide that into two equations. So y1 is my positive square root, y2 is my negative square root, and y3 is this equation up here. Now, if I plug all three of these into my calculator, make sure I can see my window is such that I can see all three equations, and I can look, and I would see that there is no intersection between these, so it would turn out to be no solution. So I don't need to do steps 4, 5, 6, and 7 here. Okay, but other problems we definitely would have intersections and would have to do 4, 5, 6, and 7. But for this example, there is no solution, and you should try that on your calculator to make sure that you do that correctly. All right, well, that is where we are going to finish for today. I know I went very quickly, so you might want to hang on to these notes and to help you with the study guide. But that's where we're going to finish for today.